Hello, Business Analytics students. Welcome to Learning Outcome 5 of the course. Learning Outcome 5 is going to be broken down into two lessons. This first one covers multiple regression. Multiple regression builds off of simple regression that we learned about in Learning Outcome number 4. Because multiple regression builds off of what we learned on regression in the last lesson, we're going to use the exact same data set. The Ames housing data set from Houses in Iowa, where we have features about houses including their sale price, the above ground living area, the quality of the house, etc., all the way to the neighborhood, which is the location of the property within this town of Ames. We still want to try to answer the question, which property features have a strong relationship with sale price, and how can we use this information to help us with pricing and marketing homes? We have the full data set that is an open data set from Kaggle provided in this table. In this first video for lesson 5-1, we're going to start on the first learning objective, which is to learn how to create multiple regression models. Last class, we used regression, or what is also sometimes called simple regression, to find different equations. One that allowed us to predict price based on above ground living area. And then we did a second regression that allowed us to predict price based off of enclosed porch area. But what if we want to be able to predict the price of a home based off of multiple variables at the same time? So that instead of having two different equations, one to predict from living area and one to predict from porch area, we could have one big equation where we could predict price based off of multiple things like the living area, the porch, and other quantitative data like the year built, the garage, etc. We can do exactly this using multiple regression. Multiple regression is a process where you create a linear equation but with more than one independent variable. We're still predicting one dependent variable, so in this case for the Ames dataset we could predict price, but instead of only having one single y-intercept and one single slope, now you'll have a slope times an independent variable value for as many independent variables as you want. So this would be slope 1, independent variable 1, slope 2, independent variable 2, etc. until you get to slope k. K just means however many you want to include times variable k. So basically it's your same equation of a line where you have slope times value plus intercept, but now not just one slope, we have plus slope 2, plus slope 3, plus slope 4 times the independent variable value in each case. I put this little person here because I like to think about it like just slapping in new slopes and variables for however many independent variables you want to use to help you with your prediction. One other important thing to recognize about this equation is that the meanings will change slightly. X still represents every single independent variable, but in this case you can have multiple independent variables. Y hat still represents a predicted value of the dependent variable. There'll still just be one of those. For Ames data, we'll use price. For the y-intercept, it's still the value when x is 0, but in this case it's not just one x, it's the value of y when every single x that you've included is 0. Also, the slope is still the change in y for a 1 unit change in x, but it's only for that specific x. So we speak about one slope at a time. The slope is the change in y for a 1 unit change in that specific x, and you have to assume that changes are not made to any of the other x's at the same time. You can only make one change at once. How you find multiple regression is using the same regression tool found in the data analysis tool pack. So in the data analysis tool pack, I'll want to find my regression tool found here, and it looks the exact same as what we did last class for simple regression. We'll just be able to go into more detail about some of the information that was in that output. Another important note is that in order to use the regression tool, All of your x's you want to use have to be in contiguous columns. What that means is you cannot skip any. So in the data set here, for example, everything you'd want to use as an independent variable x has to be right beside each other in columns. You cannot skip. Otherwise, if there's a variable you do not want to use in the middle, you'll either have to move it or delete it to get your independent variables x all touching each other in columns that are side by side. The best thing to do is look at an example. So what we're going to do is, if we go back to our data, I want to predict the sale price using every single other variable that has a number. That's 1, 2, 3, 4, 5, 6, 7 x's from the above ground living area to the enclosed porch area. I don't use neighborhood because it is text, so we're not using that right now. We're going to use the 7 x metric values to predict sale price. In order to do this, I'll go back to my data analysis toolpack and to the regression tool. For the input Y range, I have to select the sale price since it's what I want to predict. And for input X range, last class we either chose living area or enclosed price, just one at a time. When you want to do a multiple regression using more than one variable, you just select all of the variables in their columns, but the columns have to be touching. Make sure you select the names of the variables so you know which one is which in the output. And because I selected the names of the variables, I have to check the box for labels. I'll let this output into a new worksheet because I don't know exactly how much space it's going to take up. And here is the full output. Now that I have the full output, I'll copy it in to my Learning Outcome 5.1 sheet where I'm going to interpret some of the output. And then you can delete the sheet 1 that was added because we already copied and pasted the output. Now we have this multiple regression output, but I want to emphasize what we look at and how we interpret this output, what it actually means about house prices. So first, if you look at this R value, that's the correlation coefficient, which is almost 0.88. That's a very strong positive correlation overall for this regression. So that's a good thing if we have a strong positive relationship between price and all of these other variables. The other information, like the ANOVA part, we'll talk about in the next lesson, in the next video for this lesson rather. The other thing we want to look at here is specifically the values for each of the coefficients, as they're called here. The coefficients are just either the intercept or the individual slopes. So first we have our intercept value. It means really the same thing as for simple regression, but then we have slopes for each variable. So this is the slope for the living area variable. This is the slope for overall quality. This is the slope for year built, etc. Another name for those is again called the regression coefficients. So that's why we want to look at this column of information. In terms of thinking about the practical significance of what these numbers mean, we're going to go one by one and interpret each of the values. The first value is the intercept, and if we look at the meaning of the intercept, it's the y value when all x's are 0. So this means the price is negative $683,194.06 when everything else is 0. Living area, overall quality, year built, ... I can't fit them all, so I'll go to enclosed porch area, R0. So when everything else is 0, that is what the price would be if you have 0 values for all of these. I know it doesn't make sense for price to be negative, but it also doesn't really make sense to say you have a house that is 0 living area, 0 quality, 0 for years built. We're not talking about houses built in year 0 for the town of Ames in Iowa, so that's why we're getting a negative price. It doesn't mean practically that you can have a negative price, it's just where the line would extend if all of those values were able to be 0. Then everything else is a slope, and how we interpret the slope is it's the change in y for a 1 unit change in that x with everything else held constant. So basically, this means that for the first one, as above, ground living area. This is the slope for above ground living area. So what that means is as we change the slope, or as we change the above ground living area, um, as it increases by 1 square foot, the slope is how much the price would change. Because it's a positive number, it means that price increases by 48.05. But you can only change one thing at a time. So if you're changing above ground living area by 1 square foot, then the price increases, because this is a positive number, by 48.05. But that would mean you're not also changing overall quality, year built, garage, anything else. Everything else has to remain the same. Then we go to the next slope. This slope is for overall quality. So what this means is as overall quality increases by 1, that's just a point indicator, so it doesn't really have a unit. Because the coefficient or the slope is a positive, that means that price increases. Positive numbers mean an increase. And this is going to be a really big increase in price of about $21,000. But if you think about overall quality, it's only on a 10-point scale from 1 to 10. So by every one increase, you're increasing the price of the home by about $21,000 with other variables held constant. Again, that just means you can only change one at a time. For the year built, again, we have a positive slope. So that means as year built increases by 1, price increases by about $305 with the other variables held constant. I know it seems repetitive, but you have to keep saying with the other ones held constant because we can only apply one change at a time in these interpretations. For garage cars, this is the slope. It's a positive number. So what that means is as you fit one more car in the garage, as number of cars in the garage increases by 1. So if you can fit one more car in the garage, price will increase because we have a positive number by about $13,796.29. Again, with the other variables held constant because we only change one at a time. So again, a pretty big increase if you make the garage fit one more car. Then we have total basement square footage. Again, that slope is a positive number. So as basement living area increases by 1 square foot, the price is also increasing because we have a positive number, but only by about $26.48. For a lot area, again, this is in square feet of the lot, we have a positive slope. So it means as lot area increases by 1 square foot, so is a change of 1 in the x variable. How much is the change in the y? Price increases by only about 64 cents. So increasing the size of the yard is not having a huge impact on the change in the price. And finally, we get to the last value for enclosed porch. Enclosed porch has a slope of negative 11.98. This is the first negative value. So what this means, as the enclosed porch area increases 1 square foot, so for the x variable, the one that's written here beside the value of the slope, it's always increasing by 1. But because the slope is negative, that actually means the dependent variable, the price will decrease because we have a negative correlation, and the decrease is 11.98, the value of the slope. So the intercept is the value for your y, the price, with everything else being at a 0. And then all of these coefficients for slopes are interpreted as a 1 unit change in the x. How much is the y changing? In other words, for a 1 unit change in each of these features, how much is the price changing? All these slopes are positive, which means all these first 6 slopes, I should say, are positive, which means that as these values increase by 1, the price will increase. But we have one negative slope for enclosed porch, which means that as the porch area increases, the price will slightly decrease. So this is our first multiple regression model, and we can use these results from the multiple regression model in order to try to predict the price of a house based on many features of the house, like the living area, quality, year built, the cars that fit in the garage, the basement square footage, the lot area, and enclosed porch, which is going to be part of our next step. So in order to actually use this model to help you make a pricing decision that is helpful in a real business situation, please proceed to the next video and we'll learn about prediction.